Hey Geometry, this is a quick review of the quiz you took. Small note, it says 1-1 to 1-3. Really, you weren't tested on 1-3 on this, so this is a 1-2 and 1-2 here. We're just going to do a quick recap of what the possible answers were and why they were the possible answers that they were. We'll go back and forth because each question on one quiz is comparable to a question on the other. So we'll go back and forth. On number 1 on quiz A, we only had 2 points to worry about, P and B, and we had arrows at both ends. Since we had arrows at both ends, we'd say these are line PB and line BP. We can reverse the order of the two letters to name a line or a line segment. But we're using a line because we got an arrow on both ends. This line goes on forever in both directions. Similar question on number 1. For quiz B, we had 3 separate points, but our line had arrows at both ends, telling us that it was a line. We had arrows at both ends, it was a line. We just needed to name it with pairs of letters. So V to B, where V to B would have worked. V to S, or S to V. Then B to S, or S to B. Either of those names would have worked because it needed 2 letters with arrows pointing to the left and right on our name. These are just different ways to name our lines. Again, this is a line. Because it goes in both directions. Goes forever in both directions. Or in 2 directions, we'll say. Number 2, we're dealing with naming a line segment. We know it was a line segment because it's ending. We don't see any arrows going on. Line segment. Has a pair of endpoints. Now, we were looking for, and I only graded for, E to T or T to E. I was looking for those sorts of pairs, the phrase line segment, T to E or E to T, because those are the ends of that line segment. In a similar fashion, L to A or A to L were the names of this line segment. There are smaller line segments as part of it. We could say AH is part of AL. We could say HL is part of AL. We could say TW is part of TDE. But the H and the W are not the ends of the entire figure, so they're not endpoints, so they're not going to be named names of those line segments. Last naming lines sorts of situation, we had rays. A reminder, rays have 1 endpoint. So we see, this case, D has 1 endpoint. It doesn't go on to the right, it goes off to the left forever. Our rays are named by that endpoint, so we have to start at D, and we pass through F, or we pass through M. Those were the possible names. Notice the arrows pointing to the right. The arrow on a ray, when you're naming it, should always point to the right. And even if your picture points to the left, the arrow in the name points to the right. So we start at D, passing through F, or we start at D, passing through M. Similar over here, we start at E and pass through A to get us ray EA. We have E passing through H, giving us ray EH. Alright. Progressing on. We're going to talk about the names of the planes here. Over here we see Q, Y, U, and T. Sorry, not Q. X, Y, U, and T. To name a plane, we need to use any three of those letters that are in the shaded box that is matching up with this box on our cube or on our rectangular prism. If it doesn't look like it's matching, it's probably not in that plane. We see X and Y and U or T in this plane. We're just going to name them with any 3 points. So in this case, TXY or UTX, in any order. We could have taken 3 of these letters written down in any order. All we need are 3 points that are not in a line to name a plane. And these 3 points, any 3 points we pick here would not be in one continuous line. In a similar manner, we see the plane here. Now, the plane is, in this case, going at a slant. It's going at a diagonal through the boxes. So P is not on our plane. It's at the back of our plane. It's behind it, actually. R is not in our plane. It's actually in front of it. The points that would be inside of our plane, if we just sort of trace them, we have the shape that looks like our plane there. Looks like T, S, N, and M. And that's what we see here. We see these 4 letters, M, N, S, and T, could have been named in any order as long as we had 3 of them. I was only accepting it if it had 3 letters. If it had 4, I was ignoring it. Sorry. You only need 3 letters to name a plane. We'll use 4 letters in the future when we're naming particular quadrilaterals. But right now, just trying to name a plane, which goes on forever, we only need 3. Taking a look at our naming of angles here, we're going to see some similar back-to-back. We see this marked angle here. To name that angle that's been marked, we need to start away from it, come inside, and then leave. We can sort of name it based on the rays that it's making. So we see K to N would be a ray, we see K to L would be a ray. We're going to name this angle based on the 3 letters that make up those 2 rays, N, K, L, or L, K, N. Notice that K is the center point of this angle. It's also the center letter when we're naming it. Over here, when we had just a triangle all by itself, we didn't have to worry about whether M was part of it. We were able to name it just a handful of different things. We were able, in this case, just to call it E, because it was all by itself. I couldn't call this K, because K could have been 3 different angles. It could have been the highlighted one. It could have been this second smaller angle here. It could have been the large angle. It could have been the obtuse angle here. Because we don't know, we don't call it K. We have to use 3 letters here because it's unclear what angle K by itself refers to. Over here we've got E all by itself with just 2 lines coming from it. It is perfectly fine to name this angle E. So we could just name it the angle because that is the 1 point, E. But we could also do the approach by naming it based on the rays that we're dealing with. We could go from C through E to D, or we could go from D through E to C. DEC or CED are the possible names. Those are questions 5. Question 6 is basically the same idea on both of them. Questions 7 and 8, draw a picture. It helps to draw a picture. Point T is on the line segment SU, so draw a picture and put at the ends of the line segment S and U. We need to put T somewhere on the line segment. I'll just place it here. It doesn't matter for our picture. And we can fill in what we know. S to T is 9. T to U is 7. We want the length from S to U. Well, we can just add 9 plus 7 to get the total length of 16. We have a similar thing on this, number 7. D is on the line segment from C to E. Let's draw our line segment. From C to E, let's put a point somewhere in the middle, label it D, and fill in what we know. In this case, we know C to E, the entire length, is 16. And we know D to E is 6. If the entire length is 16, and this part is just 6, CD has to be 10. That was 7 for both of those. 8 is the same idea for both of those. Draw a picture, label the picture, or label the segments of each picture, and find the missing lengths. Draw the picture, label the picture, and find the length. Draw the picture, label the picture. P to Q here is 2. O to Q is a total length of 19. Find the missing length. Last is to take a look at 9 and 10 for both of these. We'll take a look at 9 for both of them, and that will be probably enough to get you through 10. Nine and 10 are similar to 7 and 8, but we just have equations now. We have to do some math. But to even set up the math, we need to draw a good picture. So, U to W with point V somewhere on the line. I've put V somewhere on the line. And I've labeled things. V to W is X. U to V is 3X minus 1. And U to W, the entire length, is 5X minus 5. We're going to write an equation for this. For the equation we're going to write is say, hey, this length here plus this length here should add up to make 5X minus 5. We'll write 3X minus 1 plus X equals 5X minus 5. We'll combine some like terms. On the left-hand side, we'll combine the 3x and the x to get 4x minus 1 equals 5x minus 5. We'll combine like terms again by adding 5 to both sides, canceling out the 5's on the right-hand side. 4x plus 4 equals 5x. We'll subtract 4x from both sides. giving us 4 equals x, or x equals 4. Notice that's what we have, x equals 4. The last thing we knew was identify what v to w was. Well, v to w was also x, so just plug in our answer. V to w has to equal x, which is 4, so vw equals 4. Let's see the same idea with number 9. We drew our picture, I to k, with a point j somewhere on it. We labeled j to k as being 2x minus 1, I to k is 3x plus 2, and I to j is 3x minus 5. And we write an equation about this picture. ij plus jk should make ik. We're just using segment addition postulate. ij plus jk should equal I to k. 3x minus 5 plus 2x minus 1 should equal 3x plus 2. Combine some like terms. On the left-hand side, we get 5x minus 6 equals 3x plus 2. We'll combine like terms. We'll solve for x by subtracting 3x from both sides. We'll add 6 to both sides to make the minus 6 go away and to make the 3x go away, leaving us with 2x equals 8, or x equals 4. X equals 4. The last thing we need to do was know what jk was. Well, we knew j to k had this equation, 2x minus 1. So we'll go j to k is 2 times x is 4, 2 times 4 minus 1. We evaluate that, we get 7. I'll give you a chance to take a look at 10. These are the 2 pictures you should have had that would have helped you set up and solve this problem. Solving number 10 on Form A. Solving number 10 on Form A, you should have had 14. Solving number 10 on Form B, you should have had x equals 5. The equations you could have written once simplified, or the equations you have written are x plus 2x plus 4 equals 4x minus 10, and 2x plus 2x plus 4x minus 10 equals 4x. Those are the 2 equations you would have wanted to solve to find out what x is. Once you had x, you would want to take your answer and plug it in to find PR and IJ. That is the little bit of review here.